Hello, so welcome to today's episode of Iodica Tries to Teach You Physics. So today we're working on the problem that's known as the power winch. So basically what happens is there's a 41.8 kilogram skier that's being pulled up a hill by a motorized gear. The snow that is built up on the skier's skis creates a coefficient of kinetic friction between the skis and the surface of 0.05. The skier is pulled up the 22-degree incline hill at a constant rate of 1.04 meters per second. So how much power must the motorized gear supply? So obviously the first thing you do is draw out the scenario and what exactly is going on here. So, so you got the skier right here, you got the 22-degree incline, and you got like the little turbine or whatever it's called just pulling up the skier. So the first thing you do in anything involving forces is draw a free body diagram. So as you can see, you have your mg, your force mg, you have your normal force, you have the kinetic friction going against the direction that the skier is trying to go, and then you have the components of those forces, more specifically the Fg components. You have Fgx and then Fgy. So in order to find the power, so we're looking for the power for how much power is needed in order to get the skier up the hill. So the formula we'll be using is the total force times velocity. So how would you get the total force? You do total force is the kinetic friction plus the component of Fgx, or the x component of the gravitational force. And then in order to get the kinetic frictional force, you have to use Fk equals mu k. Mu is the kinetic friction coefficient times the normal force. And then how you get the normal force, it's literally just mg cosine theta, because again we're looking at the x component of it and you're going up an incline, so that's why cosine theta is involved here. And so Fk equals mu k times normal force. And then how you get Fgx, it's mg sine theta, and the reason why, even though it's on an x component, it's sine theta, not cosine theta, because right here you can see that this is theta, and then cosine is always like going towards theta. So theta is going towards y in this case, so that's why Fgy would be mg cosine theta and not x. X would be sine theta. So in order to actually like compute all this, so you're getting the kinetic friction, mu k, or kinetic frictional coefficient is already given, it's 0.5, times the mass, 41.8 kilograms, times g, 9.81, times cosine of theta, 22 degrees. Make sure you're working in degrees and not radians. I've made that mistake before. So you get your Fk to be 19.0099 newtons. And you can round that up to 19.001 newtons. So in order to get the total force on the x direction, you have to add the frictional force, kinetic frictional force, plus Fgx, or the gravitational x component. So we already have the formula for getting Fgx, which is literally just mg sine theta. So Fk 19.01, we already solved for it, plus Fgx, that's 41.8 kilograms times 9.81 meters per second squared, times sine theta, sine 22 degrees, and that's 172.6 newtons. And then the power is the total force times the velocity, and then you already got the total force, 172.6 newtons, times the velocity, that was already given, 1.04 meters per second, and then in total you get 175 watts, because power is like literally the amount of force or like work done in a certain number of times. So it's like you're getting this many newtons of force per like velocity unit, and then you're just multiplying it essentially. So this is the full work. And yeah, thank you.